Okay, today you're going to be looking at how can definitions be written as conditional statements. A conditional statement in geometry is just a logic statement. There's different rules that apply, but in geometry we use about half logic and the other half measurement. You listened and watched the story If You Give a Mouse a Cookie, and in that book you heard a lot of if-then statements. Anytime you heard the word if followed by then something, that's a conditional statement. Okay, so I'm going to kind of guide you through your notes today, but if anytime you want to write something down and you don't have enough time, just push pause on the video and then you can resume it when you're done writing. So the first thing that we're going to look at is if-then statements. An if-then statement has exactly the words if followed by a then. So an if-then statement is made up of two parts, and make sure you get this in your notes right here. An if-then statement has a hypothesis and a conclusion. And in geometry, we represent the hypothesis with the letter P and the conclusion with the letter Q. So a hypothesis is something that you think of, something that is stated, and a conclusion is a summary that's gathered from your hypothesis. So in the first statement we have, if it is Wednesday, then it is Deer Day. There's two parts to that, and you can see the colors correspond, but our hypothesis here would be it is Wednesday. Okay, that would be the statement. Then what we can conclude from that is that then it is Deer Day. So your hypothesis, the P, is if it is Wednesday. The conclusion is then it is Deer Day. Okay, here we have another example. If you are in Miss Biancat's 7th hour, then you are in geometry. So our hypothesis here is you are in Miss Biancat's 7th hour, followed by our conclusion, which then means you are in geometry. Now we're going to practice writing some of our own if-then statements. When you write an if-then statement, you always start by saying if P, and remember P is your hypothesis, then Q, and remember that Q is your conclusion. So you start with an if, state your hypothesis, and then write then, and then state your conclusion. So if we look at this first one here, it says, studying will allow you to pass the Chapter 2 tests. So we need to think, if what, then what happens? So if you study, then you will pass the Chapter 2 test. May or may not always be true. Make sure you get this statement written down. If you study, then you will pass the Chapter 2 test. And remember that if you study is your hypothesis, then you will pass the Chapter 2 test is your conclusion. Okay, here's another one. A polygon with 4 sides is a quadrilateral. Work on your own to write your own if-then statement. When you're finished, resume the video. Okay, you should have, if a polygon has 4 sides, then it is a quadrilateral. A polygon has 4 sides is our hypothesis, and it is a quadrilateral is our conclusion. Okay, so now we're going to be writing 4 different kinds of if-then statements. The one that we're already familiar with is just simply taking this statement up here, all birds can fly, and turning it into an if-then statement. So we need if something, then something. Remember, P is our hypothesis, and Q is our conclusion. So that's what this notation here means. If you have the hypothesis, then you have the conclusion. So, if it is a bird, then it can fly. It is a bird is our hypothesis, and it can fly is our conclusion. Now, once you have your statement, you need to decide, is this true or false? So you need to think, could you prove it wrong, or would you always agree with it? If it is a bird, then it can fly. In this case, it's false. I can prove it wrong by saying an ostrich is a bird, but it cannot fly. So it's not necessarily true that all birds can fly. The next type of if-then statement is called the converse. The converse basically takes this if-then and flips it around. So this time it's going to say the conclusion first and then the hypothesis. We still start with our if-then, but now instead of stating our hypothesis first, we're going to state our conclusion first because it's Q, then P. So if it can fly, then it is a bird. Now you need to decide, is this true or false? In this case, it's also false. A bat can fly, but it is not a bird. So not all things that fly are birds. The next type of if-then statement is the inverse. So one thing you need to notice about the inverse is the word in. Here's a trick how to remember this. The inverse statements add something in to the statement. In this case, it adds in the word not. Okay? So we're going to take the if-then statement, because it's the hypothesis and then the conclusion, and we're adding a not in front of it. So I will still have the if-then, but now I'm taking my hypothesis, which is P, and I'm adding a not with that hypothesis. So if it is not a bird, then I need to take my conclusion and put a not in front of that. Then it can not fly. So it's simply adding a not to the if-then statement for both the hypothesis and the conclusion. You need to decide, is this true or false? In this case, it's also false. A butterfly is not a bird, but it can fly. So it's not necessarily true that all things that are not birds cannot fly. Okay, and our last statement is the contrapositive. Now the contrapositive basically takes the inverse and flip-flops it. So in this case, I will still have the if-then, but now I'm going to state the conclusion first and then the hypothesis with adding both not in it. So in this case, if it can not fly, then it is not a bird. So notice how the inverse and contrapositive are just reflections of each other. Now you need to think, is this true or false? And in this case, it's false, because I can say a penguin cannot fly, but it is a bird. So it's not true that all things that cannot fly are not birds, because we do have some birds that can't fly, but they are still birds. Okay, now you're going to try writing your own conditional statements here. So go ahead and read the statement. An Olympian is an athlete, and I want you to fill in the written phrase, the true or false, and if it's false, provide a counterexample. So pause the video, fill the chart out, and when you're complete, you can push play, and I will go through the answers with you. Okay, so here's what you should have. For our if-then, we have if a person is an Olympian, then they are an athlete. This is true. All people that are Olympians are also athletes. For your converse, you have if a person is an athlete, then they are an Olympian. This is false. Not all athletes compete in the Olympics. And for inverse, you have if a person is not an Olympian, then they are not an athlete. This is also false. Some athletes are not Olympians. Some athletes do not go to the Olympics. And last one, contrapositive. If a person is not an athlete, then they are not an Olympian. This is true. Okay, and there is a picture on the next page if you want to take a guess. You can go ahead and pause, take a guess, and your answer is jellyfish. Last one, a little geometry. You have an angle that measures 30 degrees is acute. So go ahead, provide the written phrases, and then decide true or false. Okay, so here's what you should have for angles that measure 30 degrees being acute. So if an angle is 30 degrees, then it is acute. That is true. For your converse, if an angle is acute, then it measures 30 degrees. This is false. Acute angles are any measurement less than 90 degrees. For your inverse, you should have, if an angle is not 30 degrees, then it is not acute. This is also false. A 50-degree angle, which is not 30 degrees, is acute. That proves it wrong. And last but not least, you have your contrapositive. If an angle is not acute, then it is not 30 degrees. This is true. Angles that are not acute are also not 30 degrees. And you have a picture here. One last one. Go ahead and pause and take a guess. And it is Gatorade. Okay, you have a worksheet that you're going to complete. If you have any questions, you can ask me on Friday or come in during homeroom and I'd be happy to answer them.